All right, so let's take a look back at our quadrilaterals doodle notes from yesterday. So I want you to be on the front side there that says parallelograms, because today we are going to focus solely on parallelograms and nothing else. Okay, so if you look back at that first picture, so if you don't have a picture of that, or if you don't have that written down, I would definitely take your phone and take a picture of it, because you 100% need that for today. All right, so we today are solely talking about parallelograms and nothing else. Okay, so we're only going to focus on this front section. Okay, what is one thing you remember from parallelograms from yesterday? What do they have? Tell me something you know about it. Parallelogram has what? It's a base word there, friends. It's got two pairs of parallel sides. Good. So the top and bottom are parallel, left and right are parallel. What else do you know about those same two sides? They're parallel and what else? Congruent. Very nice. So they are the same length, right? Same distance. They are also parallel, which means they'll never touch. They'll never intersect each other. Good. Opposite angles are congruent. What does congruent mean? The same. If they are opposite, what does that mean? How is that located? Opposite means what? Yeah, but like in this picture, where are opposite ones located? Opposite, like across. Yeah, opposite sides. Good. So this angle 100 and this angle over here, they're across from each other. They're both 100. So if they're across and they're the same, I should probably do what with my equations if they would be the same? Set them equal if they're the same. If I have two angles that are next to each other, what happens with them? They're what? I add them together, and what should they always equal? 180. Very nice. So they are consecutive angles are supplementary, adds up to 180. Good. The diagonals in this picture are which parts? Which part's the diagonal in this picture? I don't know, just what's the diagonals? Where are they located? What parts of them? What color are they in my picture? They're the green lines. Yes, here's my diagonal here and here. And what do you know about those diagonals? They intersect and what happens when they intersect? What's the special type of intersection that they have? Starts with a B. Bisect. What does that mean? Cut in half. Very good. So you're going to see today our diagonals that are going to be cut in half, which means what about the two pieces that are left over? If they're cut in half, what does that mean? They're the same. Exactly. So you're going to have a lot of things today that are exactly the same. If they're the same, we're going to set them equal. If they are supplementary, we're going to add them together and set them equal to 180. So you really only have two choices today. Either add them together if they look different, or if they look the same, set them equal. That's it. Those are your only two choices for today. So let's start. Make sure you're on the side that says notes, because there's two different sides. So make sure you're on the side that says notes. I would just take that and I would just push it off to the side, but keep it out so you can look at it and refer to it. And then we're going to get started on our notes side now. Okay, so for questions 1 through 6, we're going to do some together. You're going to do some on your own. We are going to solve for x. That's all you have to do is solve for x for 1 through 6. And then it says each figure is a parallelogram. So every picture on this activity or this worksheet is a parallelogram. So they all have the same properties. So let's start. Take a look at number 1. You're given two side lengths, TW and UV. What do you know about those two side lengths? So look at your picture. What do you know about those two side lengths? They're parallel to each other, so I'm going to mark that. What else do you know about these two side lengths? They're parallel and what else? opposite of each other, and what else? Opposite sides are parallel and congruent. What does that mean? They're the same. Okay, so here's a tick mark, here's a tick mark. Well, if these are the same, what should I do with them? Set them equal to each other. That's it. So I'm going to take 4x plus 5 and set it equal to 6x minus 3. It's just going to be a day full of algebra. I'll tell you that right now. That's all it is, algebra. Okay, what should I do first? Yep, move my x's. So I'm going to move the 4x because it's smaller. So I'll subtract 4x. I get 5 equals 2x minus 3. Now what? Add 3 on both sides. I get 8 equals 2x. And then my last step, divide by 2. What do you get for your x value? 4 equals x, or x equals 4. Do I have to do anything else for that problem? Nope, and that was it. That was the whole thing. So all that we're doing today is we're taking algebra equations and we're just putting them to a picture, essentially. So it should be a relatively easy day. Questions there? All right, I'm not going to do every single one with you. You're going to do some on your own. I'm going to do 2, and then I'm going to do 5 with you. All right, number 2. Now, what do you notice is different about number 2 than number 1? This time it's got a degree symbol, so I'm talking about angles. Now, if you're looking at these angles, are they opposite angles or are they consecutive angles? So opposite angles across or consecutive angles right next to each other. What are they in this picture? They are opposite angles. So what do you know about opposite angles? They are congruent. So let's mark that in my picture. Arc mark, arc mark. These two are congruent. So if they are congruent, what should I do with them? Set them equal. That's it. Good. So I'm going to put 7x plus 17 equals 94. Right? Set them equal because they are congruent. So it's a quick algebra problem. I'm going to subtract 17 from both sides. I get 7x equals 77. Good. And then last step, divide by 7. What do you get for x? 11 what? Ah, very nice. This time it is degrees because we're talking about angles. Okay, so far we've realized if things are congruent, we set them equal to each other. Additionally, I even tried to kind of show you that. I don't know if you saw this yesterday, but if you look at your doodle notes from yesterday, on the back side where it says vocabulary there, it says, if they are congruent, they're the same. Set equations equal. Bisect means cut in half. Segments are congruent. Set equations equal. Supplementary means add up to 180. So I tried to write the equations or try to like give you a little bit of a cheat sheet. So as you were working through, you go, oh, they're congruent. I should set the equations equal, right? And so on. So that is back there in case you didn't know that from yesterday. All right. I lied. I'm going to do 3 and 5 with you, and then you're going to do 4 and 6. Number 3. Now, what do you notice about these two angles? Ah, they are next to each other. Next to. So if they are next to each other, they are consecutive. What does that mean about the two of them? Good. They add up to 180 degrees because they are not the same, right? And you can just look at the picture and see that angle Q is definitely a lot bigger than angle R. They're not the same. So my equation is going to be angle R plus angle Q. I'm going to set that equal to 180 degrees. So I've got 12x minus 5 plus 125 equals 180. There's my algebra problem. What should I do first? Which like terms can I put together there, Cooper? Beautiful. -5 and 125. What is that if I put those together? 120. Good. Okay, what comes next? Subtract 120 from both sides. I get 12x equals 60. And then my last step. Divide by 12. X equals what? 5 what? Very good. 5 degrees. Make sure if it's an angle, you put a degree symbol with it. But make sure too, though, that if it's not an angle, you don't put a degree symbol with it. Okay, so make sure you're being very careful to look at the problem. Beautiful. All right, we're going to skip 4, and we're going to do number 5. And you're going to do 4 and 6 on your own. All right, take a look at number 5. Now, what's different about number 5 than the ones we just did? It's got 3 angles. It's cut in half. Okay, so this right here is a diagonal. It goes through J to L. So essentially, it takes my parallelogram and it turns it into 2 smaller triangles. Now, you've got angle K right here is 124x. You also have, don't let this fool you, you still have one full angle right here as angle L, right? So you've got angle K here, and this entire thing is angle L. Now, if you were to look at angle K and angle L, are they next to each other or are they across from each other? These are next to. So if these are next to each other, what does that mean I can do? Add them up and set them equal to what? 180. Okay, so I want to take the entire angle K plus the entire angle L and set it equal to 180. So angle K is 124x plus, what is angle L? How did you get 56? Yeah, you just add together 27 and 29. So you can either do it first and just write 56 here, or you can write out plus 27 plus 29, right? Because that gives me the total angle L. And then it just becomes algebra. So if you didn't combine the like terms already, you'd have to combine them and get 56. Then you would subtract 56 from both sides. I apologize, there's not a lot of space. You get 124x equals 124. And then what's the final step? Divide. What do you get for your x value? 1 degree. Very good. So if you divide 124 divided by 124, you get 1. 1 degree. Beautiful. All right, I would like you to try number 4 and number 6. And then we're going to have somebody, we're going to have 2 people come up to the board and actually show us their work for it. Okay, so try number 4 and number 6.
see another minute, and I'm going to need 2 people to come up to the board, 1 for 4 and 1 for 6. Okay, do I have somebody who can come up to the board and do number 4 for me, please? Number 4. Who can do it for me? Anyone at all? If no one volunteers, I'm going to volunteer somebody. Number 4. 4 is the easier one. Come on. Who wants to do number 4? You're sitting here, sit pretty. Are you number 9 or number 6? Beautiful. You want to do number? Yes, sir. Go for it. Go for it. Yes, you did. That's why you're going for it. Number 4 and number 6. Anywhere on the board where you got some space. Go for it. You don't have to be right next to each other, but somewhere where you got some space. Thank you. I appreciate you both. You're both fabulous. Okay, while Nicole's finishing up number 6, why don't you explain what you did for number 4, Bobo? So Bobo over here did number 4. So take a step to the side and tell us what you did. Tell the class what you did, not me. I know what you did. Tell them what you did. Well, why don't you tell them?
Yeah, I set the 2 equations equal to each other.
Why? Okay. Good. So 2 sides that are across from each other are congruent. So he took the 2 equations, he set them equal. Then what did you do?
Then I subtract x from both sides. It gave me x minus 6 equals 4. Then I got x by itself by adding 6 to both sides, and then I got x equals 10.
X equals 10. Thank you, Bobo. Yay, beautiful. All right, Nicole, what'd you do?
you add them. You add all the numbers that are in the triangle, and then you set it equal to 180.
Okay, why'd you do that?
Because you just do. This is what you do. I don't know.
Are they, so are the angles next to each other or are they across from each other?
They're across. Well, they're next to each other.
Yeah, they're next to each other. So when they're next to each other, we add them up to equal 180. Okay, keep going. What else did you do then?
And then I just added together the 24. Then I added 3, 24, and the 115, and got 142. And then I just got the 19x down. And then you subtract the 142 from both sides, and then you get 38. And then you divide it by 19.
You get x equals, what does it say?
X equals 2, I think.
Yep, 2, what was your final answer? 2 what? 2 degrees. Beautiful. Give her a hand. Nicely done. Thank you to the two of you. Very good. All right, so you got x equals 10 for number 4 because they were across from each other at the same thing as Bobo. And then x equals 2 because they are next to each other, so we added them all up to be 180. Perfect. Nicely done for number 4 and number 6. Yes. Yes. Okay, so we're going to do now, we're going to skip 7 and 9 for the moment. We're going to jump, I told you we're going to jump around a little bit. We're going to do 8 and 10 first, and then we'll come back to 7 and 9. So take a look at number 8. Number 8. Okay. What do you notice is different about number 8 than the other problems we've done? There are equations. Good. What else is different? What's in this picture that we haven't had in the other pictures? The x. What do we call that x? Look back at your paper. What is that x called? Diagonals. Very good. So the x's are diagonals and they bisect each other. What does bisect mean? Cut in half. So what I'm going to do is I'm going to write the word, bisect, because I want to remember that they cut each other in half. Okay, so I've given you some equations for the side lengths. I ask you to find the whole length HF. So what we're going to do is we're going to take the equations, we're going to plug them into the picture. So my first one is 2x plus 7, that's h to I. So this segment right here is 2x plus 7. That's the first piece. So that's from here to here. The second one, IF, is 5x minus 23. So that's from I to F. That's this piece. That's 5x minus 23. Okay. I want to know the full length of HF. So I have these two equations here, and I know they are bisected. What does that mean about those two pieces? Oh, Faith? They're the same. Bisect means cut in half. Keep your mask on, please. So because they are cut in half, that means this piece and this piece are the same. Put a tick mark on them to show that. So if they are the same, what can I do to them? Set them equal to each other. So I'm going to do 2x plus 7 equals 5x minus 23. And then I'm going to solve the equation for x. So first thing I should do is what? Subtract the 2x, move the smaller one. So I get 7 equals 3x minus 23. What's my next step? Add 23 to both sides. I get 30 equals 3x. And then the last step is divide by 3. So I get 10 equals x. Now, am I finished? Why? Okay, so I need to find the full length of HF. So what should I do to find that full length? Plug it into x. Now, which one should I plug it into? Does it matter? Does it matter which one I plug it into? No, why not? Oh, they're the same, right? So it doesn't matter. I could plug it into either one. Frankly, if I were you, I'd plug it into this one. This one looks a little bit easier, doesn't it? 2x plus 7. So wherever you see an x, you're going to substitute in a 10. So that would be 2 times 10 plus 7. So 2 times 10 is 20. 20 plus 7 is 27. So HI is 27. Without doing any work, what's IF? It's also 27, right? Those two pieces are 27. Now to find the whole length from H to F, what do I have to do? Add the two together, right? It's like saying Mr. Massa walked 27 steps to get to I, and then she walked another 27 steps to walk to F. To go the whole length, she went 27 plus 27, which is 54. Yeah, I know that you don't want to write out the 27 plus 27, but if I were you, because these are your notes, I would just write it out the first time, just so then that way when you go back and look at these notes later, you don't go, where the heck did I get a 54 from? That doesn't make sense. Okay. 10, 15, perfect. All right, we're going to do number 10, and then just like what we did with the last for 4 and 6, you're going to do 7 and 9, and we'll check them together. So we're going to do number 10 first, and then we'll go backwards. 10 is a little bit harder. Now, in number 10, it says, find the missing measures. Don't let the picture itself freak you out. Okay, it's just a parallelogram, and you should be able to mark a lot of things in this picture that are the same. So you should be able to see some side lengths that are the same. If you go back to your parallelogram, remember, opposite sides are parallel and congruent. So who can name a pair of sides that are congruent? Who can raise their hand and give me a pair of sides that are congruent? A pair of sides that are the same. Bobo, what do you think? Which one? NP is the same as which side? ML. Perfect. So this side here, NP is the same as this side here, ML. So if NP is 12 meters, what does that mean ML is? It's also 12 meters. Okay, so let's come over here. Here's ML. Let's write it in. 12 meters. Okay, give me another pair of sides that are congruent. Nicole, what do you think? Good. MN, I'm going to put 2 tick marks, and LP. So if MN is 10 meters, what does that mean LP is? 10 meters again. Good. So I'll come over here. Here's LP. Okay, you should see another pair of lengths that are congruent. Nicole, what do you think? Perfect. So these right here, this is your bisected diagonal. So this piece here, LQ, has to be the same as this piece here, QN. So this one has to be 9 meters. So QN is the bottom one here, 9 meters. The only other side length I have to figure out is LN. LN. What's the full length of LN? 18. Beautiful. So you add 9 and 9. 18 meters. Beautiful. Simple stuff, right? Not too bad. Now the only parts that are left are measures of angles. So now we have to start looking at some angle measures on the inside. That's what's left. Now remember, when angles are given to you, the first letter is where you start, right? So I'd start at L. P is where you go towards, and M is where you end. So really this second letter is where your angle's at. L, P, M is this angle right here. That's that angle. Now, I'm hoping that you notice something in this picture. If you had to make a guess, which one does it look like it would be the same as? Yeah, this one right over here, 62. Now, if you remember, these are parallel lines cut by a transversal. Do you remember when we talked about that? Parallel lines cut by a transversal. Are these angles on the interior or the exterior? This angle 62 and this angle over here. Are they on the interior or the exterior? Interior. Are they on the same side of this line or on alternate sides of this line? Alternate. So if you remember, these are called alternate interior angles. They are, in fact, the same. This is also 62 degrees. And right next to it, I'm going to put alternate interior angles. Okay, last one is angle MLN. So you're really looking at angle L. MLN is this angle right here. If you had to make a guess, which one does it look like? The 32. Very good. This one's also 32. Again, are these on the interior or the exterior? Interior. Are they on the same side or alternate sides of this line? Alternate. So again, you have a pair of alternate interior angles. So those angles are probably like the hardest ones out of all of it, but frankly, when it's a parallelogram, if they look the same, they are the same. Okay, now we've got 10 more minutes here. You've got 2 problems left to do. Number 7 and number 9. I'm going to help you set them up, but you're going to finish them on your own, okay? Number 7 and number 9. So if you take a look at number 7, I want to find the measure of angle T. Before I can figure out angle T, you're going to have to figure out what X is first. Now, if you look at these 2 angles, angle T and angle S, are they next to each other or are they opposite? They are next to. What does that mean I should do with them? Add them and set them equal to 180. So your equation is going to be 9x plus 5 plus 25x plus 5 equals 180. I'm not going to finish it. You're going to finish it. That's number 7. Look at number 9. Are those angles next to or across from each other? They're across. So if they're across from each other, what should I do? Yeah, set them equal to each other because they are congruent. So your second equation is going to be 8 plus 6x equals 7x plus 2. So I'm going to give you the next few minutes here to finish up 7 and 9, and we'll check it right at the end of the period. So you've got just a couple minutes for number 7 and number 9. Take some time, finish those 2.